Okay, let me take a look at your Class 19 handout. And we're going to jot down any reactions and super important concepts that we come across. There might not be a lot of reactions in this Class 19 because a lot of it was introduction, structure, nomenclature. So let me actually write that down. We had structure, hybridization, did I have any orbitals? Not really. We had nomenclature, and we had acidity. So acidity by itself is not a reaction. And so how about with acidity? Do you know how strong the base has to be to deprotonate the terminal alkyne? So can you choose a base to deprotonate a terminal alkyne? The pKa for a terminal alkyne is around 26. It's a little bit subtle. What that means is the conjugate acid of the base has to be weaker because you want to favor the weaker acid, or this as equilibrium favors the weaker acid. And so, for instance, if you have a better way to set this up actually is to say that you have an alkyne terminal which has a pK of 26. And so whatever base you choose plus some base, you'll have, I want the equilibrium arrow to favor the right-hand side, meaning that you have now your alkyne is deprotonated, plus this thing here, which is your conjugate acid, that pKa has to be greater than 26. Does that make sense? So how do we get the arrow to favor the right? Well, this is now the weaker acid. And so if you have to figure out what your acid is, what is its conjugate base, and that you draw that base here. So there are question marks, right? There are question marks here. What do you want to put there, such that you get a conjugate acid that has a higher pKa, because now we're going to determine that this is the weaker acid. Equilibrium favors the weaker acid. So I'm not going to tell you the answer, but you could imagine that if I give you 4 choices, sure, you could pick the one that's the most basic. Or I could give you 4 choices and say, hey, which of these 4 can do this reaction? And it could be 1, 2, 3, or all 4 of them. You have to decide. Does everyone understand that question? I'll give you 4 bases, and I'll say, how many of these bases can make the equilibrium arrow go to the right? Well, you just take that each base, make it the conjugate acid, and see if its pKa is above 26 or not. Okay, so I kind of like that question. Let's take a look at the first reaction. Any questions, though, before I move on? Any questions about this idea of choosing the correct base? Okay. The first reaction is, I'm trying to figure out a color. Let's do orange. Reaction 19A. That is alkylate. Okay, great. The name tells me what I'm going to do. I'm going to add an alkyl group to a terminal alkyne. Alkylate a terminal alkyne. This is useful because if your target has more carbons on it, then maybe you're adding those carbons through this reaction. Okay. And so, for instance, we'll try something like this actually. Okay. How about this alkyne? Terminal. Okay. Make sure, I'm trying to emphasize this in lab, make sure the 3 lines try to end at the same place. Okay. Arrow. How about this? Instead of me giving you the reagent, what if this is my target? How do I make that? Okay. And so what you want to do is you want to identify what bond was made. And so here I'm going to put a question mark right here. And that's alkylation. We added an alkyl group. When you do your, I call it a disconnect, draw your dotted line through the middle of the bond. So you know which carbons are existing and which carbons you had to add. That was the bond that was made. So it's very clear that I added 3 carbons. I added a carbon chain that there are 3 carbons. Does everyone see that? You know, the carbons on the starter material, 1, 2, 3, 4, 5, 6. This is C6. So on this half of the dotted line, we have C6, and I added 3 more carbons. So how do we do this? The answer. Number 1, you're going to deprotonate the alkyne. So use a strong base. My favorite for alkyne deprotonation is NaNH2, or others that are okay, but NaNH2 is my favorite. NaH, okay, or LDA. By the way, NaOH is not strong enough. Do you know why? Not NaOH. Because if OH is your base, what's your conjugate acid? It's water. OH will turn into water. Water has a pK of 15.5. So equilibrium wouldn't favor the right. 26 is weaker than 15.5. But the pKa of NH2, when it becomes NH3, that pK is 36. To see how these are a stronger basis than this. Okay? So 1 is that. 2, look at this. You added it via this blue carbon. You made a bond from the triple bond carbon to the blue dot. So your blue dot is the one with the bromine or the halogen. It could be chlorine, it could be bromine. That's the answer. Okay. I'm not going through the mechanism, but I'm going to write, definitely you need to know it. Okay? So know mechanism, or know the mechanism. And there's a really important point. Okay? If you want to alkylate is you add an alkyl group. If you want to alkylate, your alkyl halide has to be uncrowded. It has to be methyl or primary. Oh gosh. Oh no. Running out of charge. So alkyl halide has to be very uncrowded, like CH3Br or CH3Cl, or primary. Secondary and tertiary, we get into some problems because it's too crowded to attack, and we actually get elimination. Don't worry about that. Worry about how to make the alkyne and your alkyl halide. This has to be primary or methyl. So let me give you one more example and then we'll move on. How about if I drew it like this? And now I'll give you LDA. Okay, let's use a methyl halide, CH3Br. How would you draw that product? Okay, go ahead and draw that product. And so I can't draw a dot like I did over here. The dot is this carbon. But I can imagine that the triple bond carbon made a bond to the dot, kicked out the halide. And so all you're doing is adding a methyl group. Some people actually have more trouble with a smaller molecule than a larger molecule. People really have no problem with this, but when they get too small, they're not exactly sure how to deal with that. It's just that. See, there's your added carbon. If you wanted to draw the dotted line, well, the dotted line is here. Right there. Okay? That is alkylation of a terminal alkyne. This is 19. Okay. Any questions about this? I think the tricky part is that your alkyl halide has to be primary or methyl. I do have, let me show the ACE. There was only one, besides acid-base, there was only one reaction in class 19, and it was the alkylation. But let me show you the ACE set. What's happening here? Oh no. That problem is this problem. Number 5, make these alkynes, these 3 alkynes, using some alkylation strategy. And so in the box as an example, you can make either the bond to the right or to the left of the triple bond, but it depends what you attack. I'm not going to go through this whole thing, but look at trying to make bond A. If I'm trying to make bond A, the triple bond carbon's attacking a carbon that was originally secondary. Do you see trying to make bond A? I don't think I could point here. But number 2, you have that alkyl halide that's actually secondary, and it says no desired product because you're using a secondary alkyl halide. Take a look at your original molecule, the one that has A and B pointing to it. Do you see how one used to be a secondary carbon that you attacked? The one that was attacked to make bond A? To make bond B, you attacked a carbon that used to be primary. That's the top reaction. That's this reaction at the top. Okay. All right. So that's the idea for mainly class 19, or that's the main idea for class 19. How do I get out of here? Oh my goodness. Okay. Any questions about this? I'm going to stop the video. This is all of class 19. It looks like we did spend a lot of time on acidity and then this idea of alkylating an alkyne. It's really to build up a molecule. In the first example, we went from 6 carbons to 9 carbons. In the second example, we added 1 extra carbon. So we're making molecules that are getting larger and larger using this method.